All right, picking up right where we left off in the last video, we have discovered this thing called a logarithm, commonly known as log. Its sole purpose was to explain exponential inversion, okay? Inverting the exponential equation. So what happened? Well, by definition, if I have a to the x is equal to b, aka 2 to the 5th is equal to 32, which we know is true, right? We know that's true. Then what does the log look like? Then the log of a of b, that's how you read that, log a of b is equal to x. Or, with our numbers here, log 2 of 32 is equal to 5. And what that does is it spits out the power. See that? It spits out the power. When you really dig down deep to that graph we were looking at, the power was what ends up being y. You see that here? X was the exponential, the power, the exponent, and then here the logarithm actually spit out that power. That was the output now. And so that's what logs do. They show you the power that creates that equation. Let's do a couple more here. Let's just convert with facts that we know. Okay, we know these to be true equations. We know 4 squared is 16, so we want to write a function, a log function, that's going to show us the power, right? Now, there are many tricks to this. You could do a little circle. That's fine. You could switch 2 and 16. I don't care how you remember it. But basically, you write a log. The base was 4. The answer was 16, sometimes called the argument. Okay, the argument was 16. And then the power on that was 2. So what power takes 4 and gives you 16? The answer is 2. And that is your logarithmic expression. Doing it again, you can do it with anything. You can do it with fractions like this one here. We know that 1/2 to the third would be 1 to the third over 2 to the third, or 1/8. And so log 1/2, a lot of times you see people put it in parentheses to clean it up a little bit. What power takes 1/2 and gives you 1/8? That power is 3. Works with negatives as well. What power takes 5 and gives you 1/25? That power had to be a -2. Cool. I recommend you try these last 3 on your own. Stop talking for about 3 seconds so that you can pause the video and give it a shot. All right, hopefully you had a chance to pause the video. What power takes 3 and gives you 243? That power would be 5. What power, log of 1/3, takes 1/3 and gives you 9? That power would be -2. What power takes 36 and gives you 6? That power would be 1/2. These are all true statements, right? 36 square rooted is 6. The -2 on the 1/3 would flip it back over to 9. But this entire purpose of log is just to show you that power. All right, now that we've done that, let's see if we can go backwards. Let's see if we can take a log expression and make sure that it is in fact accurate. This reads as log 3 of 9 equals 2. Log 3 of 9 equals 2. But what it's really saying is that the power that takes 3 and gives you 9, that power is 2. So we can rewrite it as 3 squared is 9. Cool, and that is a true statement. All right, what power takes 1/4 and gives you 1/64? That power would be 3. Now watch out, you don't want to put the third without the parentheses because then it's not quite the same thing. But this logarithmic statement is true. What power takes 8 and gives you 1/64? That power would be -2. I recommend you try the last 3 on your own. I'll stop talking for 3 seconds so that you can do that. All right, the last 3 read, what power takes 12 and gives you 144? That power is 2. What power takes 1/9 and gives you 81? That power is -2. What power takes 49 and gives you 7? Careful, it does not give you 1/2. People try to think of this way, they end up accidentally switching it. That power would be 1/2 because we know 49 square rooted is 7. All right, the last video here, we're actually going to start solving for some x pieces, so I will see you there.